Chapter 5, Continuation of Loops. We're going to look at a couple of ways of controlling the while loop, as well as going and covering, finally, for loops. It's going to be fun. Let's go. So we've seen a couple of different ways to control a while loop. Thus far, we've used counters, we've had count variables, and we've counted a certain number of iterations, which ideally is not how you would use a while loop, but it's been fine. That does work. We're going to show you the better way of doing that now. We've also checked for some condition, such as when we did that number guessing game, and we kept looping as long as the user had not made the correct guess. So we had while guess does not equal to the number. There are also other ways that we can control the loop. We can control the loop with a user confirmation, and we can also control the loop with what is called a Sentinel value. So starting with this user confirmation, let's revisit that subtraction quiz that we ended with on the last video. If you recall, we asked the user how many questions would they like to enter, and they said they would answer between 5 and 20 questions, or so we hoped based off of the fact that we asked them to enter between 5 and 20. So we let the user control the number of iterations by entering that value. And that worked perfectly fine, but we could have done this differently. Instead of asking them to enter how many questions they would like to answer at the outset, instead, we could have just simply asked them a question, scanned their answer, told them if it's correct or incorrect, and then we could have then asked them, would you like another question? Yes or no? Or Y or N, scan their answer, and based off of that answer, continue effectively in an open-ended manner, seemingly indefinitely. So this is what we like to start with, is by asking this type of question, and then in the while loop, we'll continue looping so long as another question equals yes. So let's go see how we could possibly have done that. We're going to make a brand new subtraction quiz. We're going to start with that code from last time, and we're going to modify that quiz to make it controlled the way we just covered. And I don't want to show the code here, so let's come over to the last subtraction quiz. Let me save this with, I'll just call it version 2. V2, let me come save it here. Done. So what did we do? We had a subtraction quiz header. We asked the user how many questions they want to enter. We're not going to do that now. We're not going to have, do we need a count? Let's see. You answered blank out of blank questions correct. So we still need a count because we need to be able to, yeah, we'll use the count actually instead of num questions down here. So we're going to still need a count so we can do that math. If they've answered 3 out of 4 questions, we still need to know how many questions they answered correctly. So instead of num questions down here, because we're no longer going to ask them that value, num questions was up at the top. Let me just back all the way up. We'd ask them how many questions do they want. So if they said they wanted 5 questions, I would have down here, if they answered 4 correct, I would have divided 4 by 5. You answered 4 out of 5 questions correct. And actually, I'm not even dividing 4 by 5 for the math. I was just simply printing out you answered blank out of blank. But we put the 5 right here, and that 5 num questions was based off of what they entered at the top. But if we're no longer going to ask them this, now it's good that we have this count variable, because now we'll just simply put the count variable right here to print out how many questions were actually asked. So what needs to change? Let's see what happens at every iteration. We're going to generate 2 numbers. We're going to swap them if need be. We get the correct answer. We will print the question. If it's correct, we print correct, and we increment the number of correct, else we print incorrect. And then we increment the count for the next iteration, and of course for the next question number. So we can put question 2, question 3, and so on. So let's see here. So instead of saying while count is less than or equal to num questions, we want to do exactly what was mentioned here. And that was, we want to say while another question equals yes. So while another question equal, and I'll put lowercase y, and you know what, I'm going to make this dot lower. And I don't need to have done that here, so I'll do that when I scan. So while another question equals yes, and if you're thinking about this while just editing the code, so instead of just editing mindlessly, if you're actually thinking, you may have wondered, well, I don't have this variable another question yet. That's correct. And we'll talk about how we're going to fix that. But let's pretend that's not an issue. So what we want to do is down here at the bottom of the code, after we have asked this question, when we've told them if it's correct or incorrect, then right here we want to ask the user if they want to answer another question. So we want to do this another question equals input, would you like another question? How about we put Y or N for yes or no? So now, that's the last thing we're going to ask them within this loop. We're going to ask them, do you want another question? Y or N, and we hope they enter that correctly. We're not going to worry about user verification of their input right now. So we're going to assume they can enter Y or N correctly. And then we would increment count. And I already see one issue that would happen, that our count will be one larger, and so we can fix that by moving count. But what I want to show is that, so here, if you were to run this program right now, it's going to give you an error because another question right here in this while loop on line 16, it's saying that, hey, you're asking me to check, does another question equal Y? And it's not defined yet. So when we're trying to ask the Python interpreter, can you check for me, does this variable contain just a Y for yes? Does it contain that value? And Python's like, well, I don't know because I don't even know what another question is. We're not getting the user's answer until down here. Down here we ask them, would you please enter Y or N for whether or not you want another question. We're going to save that into here, into this variable, and then on the next iteration when we come around, then we can finally test this. But on the very first iteration, how do we effectively force our way into this loop to do it at least one time? Like, we want to do this loop once. We basically would like to have it like this. While true, for the very first iteration, just enter it and do it. And then after that first iteration, sure, keep looping as long as the user answer is Y, that they want another question. So how do we do that? The answer is hack your way or force your way into the loop by initializing another question to Y. So just make the variable another question, and we're going to set it equal to Y right off the bat, as if we had already asked the user, do you want another question? Which we haven't done, but this is the way you accomplish making that loop happen one time. So now we're going to run the loop because another question already equals Y. We're going to generate the two numbers, swap if need be, get the correct answer. We're going to scan the user's answer, and if the user answers the correct answer, we're going to print correct, increment the number of correct, otherwise print incorrect, and now we're going to ask the user, would they like to answer another question? And here's where I would probably want to just put dot lower. So you could either put that here, because remember, what does input do? Input returns to you a string of text from the user. And in case the user they could enter a capital Y or a lowercase y, which means we could have up here said while another question equals Y or another question equals capital Y. You could have done that. So now you're testing both options. Or we could have just said, you know what, get the user's input and lowercase it. This is a string method that will take the user input or take the string and will make it lowercase. So we could have put dot lower right there, or I could have put dot lower right here instead, which is what I'll do. This is just saying take whatever the user inputted and let's make it lowercase, and let's see if it equals a lowercase y. I could have put upper and checked to see if it equals an uppercase y. I hope we see why it would be a fail if I made it uppercase and I said, let's see if it equals a lowercase y. That would be a very big brain moment to make it uppercase and then hope it would somehow equal a lowercase y. That would be an epic fail. So let us come right back. I think we're now good, except our count is going to be off, and let's run that so you can see it. Question 1, 3. Would you like another question? Yes. Question 2. And so the formatting's not nice. I'd like to put this, would you want another question? I see right here, I'd like that to be one more line down. Maybe we'll put 4 spaces in front of it so it looks nice. So let's put a new line, and then let's put 1, 2, 3, 4. Let's start this over and see if that looks a bit better. Question 1, 9 minus 5, 4. Would you like another one? Yes. Question 2, that looks better. 8 minus 3. 8 minus 5 is 3. Would you like another one? Yes. Question 3, 5 minus 3. Let's put a wrong answer. Incorrect. Would you like another question? Yes. And let's answer this one correctly now. 2. Would you like another question? No. So notice it says you answered 3 out of 5 questions correct, even though we only had 4 questions. Why is that? Did you already pick up on why that happened? So the reason why that happened is simply because we started count at 1, and we used that count value right here to print the question number, right? And then we incremented count at the end of the loop. Nothing wrong with that, but the consequence is that when we finish, if they say right here, nope, they don't want another question, and then we increment count to question 5, and we come up here and we exit the loop, the suggestion is somehow that they've answered 5 questions. So to fix that, you could simply come put count minus 1 right here and recognize that count really was only 4. Or we could do the following. We could increment count at the beginning of the loop, which I'm going to do. Let's increment count right here at the beginning. And therefore, let's start count at 0 instead of at 1. So now, let's run this and test it. Question 1 is 2. We want another question. Question 2, 3. Let's do one more. Question 3 is, let's answer this one wrong. And we don't want to do another one because we're sad because we got it wrong. And there we go. You answered 2 out of 3 questions correct. So here was an example of controlling a loop with a user confirmation. And here was the code and the slides showing pretty much the same thing, but making this another question equals y before the loop, and then forcing our way into the loop with that, and then constantly checking at every iteration, do you want to answer another question? That's how we would that's how we could use a user confirmation to continue our loop. Another means of continuing the loop is using a Sentinel value, is designating a special input that will be used to stop the loop. So consider this following example. If we want to write a program that will repeatedly ask the user to enter an integer, and your program should sum up all of those values, saving the result into a variable called sum, your program should also count how many values were entered, saving that amount into a variable called count. And then finally, your program should stop reading values as soon as the user enters a 0. So as always, we have a problem-solving phase before we implement. So step 1, what is the design strategy we covered previously? We want to think about what needs to occur inside the loop. So back up, what do we say? We're going to constantly ask the user to enter another number, enter another number, enter another number until they enter 0. And when they enter a new number, we're going to do what? We're going to add that number to a sum. We're going to increment count, a count variable by 1, and we're going to keep doing that, rinse and repeat over and over and over. So ask the user to enter a value, add that to a sum, increase count by 1. Let's go ahead and do that. So here's I made a new program, sum until Sentinel. You should do the same. And let's look at what we want to do. I'm just going to put a lot of spaces in here. Let's come up. We want to do what? We want to ask the user to enter a number. So I'll call it number equals int input. Enter an integer. Stop loop stops when you enter 0. Good enough. Okay, so we asked them to enter a number, and then we're going to do what? We're going to add that number to sum, which means we need to make two variables. Variables needed for program. Sum is 0 and count is 0. So we're going to add this number that we read in, we're going to add it to our sum. Sum equals, sum plus equals number, and we're going to increment our count, right? So let me put this as comments here. Add number to our running sum, increment count. So that's what needs to happen. Now it said wrap those statements inside a while true block. And then finally add the condition of the while loop. We won't do that in a while true block just yet. So let's show you what I did here. So we'll talk about the while true block, how I can improve upon this. So basically, if we did not use a while true block, if instead because the loop design strategy was sure, use a while true block. So let's go ahead and do that. While true. And then we come highlight all of these lines of code that we identify need to occur multiple times. So this was the strategy. So you can keep doing this over and over. And let's do 5, 1, 4, 8, 2. Finally, we hit 0. And of course, it's not going to stop because it's a while true, no problem. So now how do we exit? Well, we're going to exit when number, or we're going to keep looping, or let's do this. Put a comment. Keep looping so long as number does not equal 0. So once you put that comment very clearly, you can easily come in here and say, oh, well, the code is now easy. While number does not equal 0, keep looping. Well, so then now you realize, oh, wait, since I'm saying while number does not equal 0, and that's the condition of the while loop, but I don't know what number is on line 7, then you're like, oh, wait, same thing as that last example. I need to somehow, before the loop, come out here and set number equal to something, but not 0. Because if I put number equals 0, then you'll never enter the loop. But then if you put number as, you could put number as a fake number, because that'll force you into the loop. And we're going to immediately go ahead and overwrite number right here. And so that's going to work. I'm going to go ahead and do it that way because that'll be different than what you'll see in the slide. Because on the slide, what I did is, and I don't like the solution, but on the slide, I basically asked the question outside of the loop. Then inside the loop, as long as number was not equal to 0, which we scanned on line 6, I added number to sum, I incremented count, and then I scanned number again. That's what you see here as the solution. That I ask, enter the integer outside of the loop, then as long as that value does not equal to 0, add it to sum, increment count, and then ask again. So that works just fine, but just so you can see a different approach, let's just make number equal -1 outside the loop. What does that do? That effectively forces your way into the loop, right? Because here it says keep looping as long as number is not equal to 0. Well, we're saying, you know what? Let's set number equal to something other than 0. You can make it your favorite number, 777. So all of a sudden, that's not 0. We're going to enter the loop. No harm, no foul. Don't be worried about, but what's going to happen? Will I add 777 to sum? Or will I do something else? No, because what's the very first thing inside the loop is we overwrite what is inside that variable number. So I'm going to set it to -1. And inside the loop, we're going to scan an integer. We're going to add that number. I want to put the comment afterwards. Feel it might look a little cleaner. We're going to add that number to our sum, and then we're going to increment our count. So that is pretty straightforward. And then afterwards, of course, we want to print the results. What did I print here? You entered this many values. Cool. Let's do the same thing. You entered blank values, which sum to blank. Good enough. Dot format. They entered count values, which sum to sum. And let's check that out. Let's run this now. Let's enter just 3 values. 1, 2, 3, and 0. You entered 4 values, which sum to 6. So why did we get 4 values? Well, because it's counting that last value, which we don't really want to count as one of them. So here, when they enter an integer, 0 to stop, notice that we're still going to add 0 to sum, which doesn't hurt sum, right? Adding 0 to 6 did nothing, but we are adding 1 to count. So now count became 4, and we don't really want it to be 4. We only really wanted to count the non-zero values. So what could you do? You could have come right here and put count -1 to correct that. And so once again, when I come and we put in the sample input 1, 2, and 3, adds up to 6, 0. You entered 3 values, which sums to 6. All right. So limitations of that Python loop structure is often you want to run your loop at least one time. And that was what we wanted to do here, right? We wanted to run this loop one time, and then after running it once, then and only then do we want to possibly not run it again. But we want to run it at least once, which is why we had to like force our way or hack our way into the loop by saying, you know what, number equals -1. So therefore, this is always going to be true, right? Because -1 does not equal 0. And we've forced our way into the loop. So many times you have a loop situation where, or a problem set up where the design of the problem is you want to run the loop at least one time. At least one time, and that's what we needed in that last example. Many languages have what is called a do-while loop. And the construct of a do-while loop is such that you will do the loop once, regardless of any condition, meaning that there will not be a condition where you have to say while something, if I can type correctly, do all of this stuff, right? Whatever you want to do. And we have to check the truth of that something. That's not how a do-while loop works. A do-while loop does not exist in Python. It does exist in most other languages. And it would be something like this. Do all this stuff at least once. And then afterwards, you would have something like this while something. So you would do it at least once. And then do you do it again? Well, now we check the condition after doing it one time, and we check should we do it again. So the difference between a while loop and a do-while loop is that a do-while loop, you're going to do it no matter what at least one time because these lines of code happen unconditionally. And that's a good construct. Most languages have a do-while loop. And again, what's the purpose? If you have a problem, and the setup or the design of that problem is such that you want to do it at least once, regardless of any condition, that's when a do-while loop is valuable. And it would have been more appropriate on that last problem we just did. So Python does not have a do-while loop. What is a workaround? If you would like to at least do your loop one time, the problem is simple, and honestly, it's my favorite looping structure. And that is, we're going to make this as a while true loop. So just come right here and you type while true. What does that mean? It means you're always going to do that loop, certainly one time. In fact, indefinitely. It will happen over and over and over and over. So we're going to get rid of this forcing your way into the loop. We put while true here, which really means it will never end, but no problem, because check what we're going to do. Right here, after we scan the number, we're going to put an if statement. Check if number is 0. If so, stop the loop. So if number is 0, how do we stop the loop? We type the word break. So if number is 0, we break. What does break do? It literally just completely stops the loop in its tracks. So if I come over here and I debug this, let me hit next, step into. So now we're at a while true. We're going to scan a number from the user. Let's enter 0 right off the bat. And so hit enter. And so now number is 0. If 0 equals 0, break. What happens when we break? We exited the loop and we go to line 18. So the value of this while true loop is it's simulating this idea of let's do the loop at least one time, no questions asked. So now we're going to come in here, we scan the number. If the number is 0, we break. If it's not 0, we're going to add number to sum and we're going to increment the count. So that's another way, a very effective way of controlling while loops with this while true. And then inside the while true, you put an if statement. And if that condition is met, then you would break out of the loop. So here is how we could have redone that loop, which I just showed you on the slides, or in code, in Thani. So here, we have 3 snippets of code, and let's look at each one of them and try to determine how many times are those code snippets repeated, and what is the printout of each. So when we look here at A, I starts at 1, while I is less than 10, 1 is certainly less than 10, so that's true. If 1 mod 2 equals 0, we want to print. So 1 mod 2 is 1 even. That's really checking if it's even. It's not even. If it were even, we would print it. So think about how many times that's going to execute. Pause the video and then come back after you have an answer. The answer is that's going to execute infinite amount of times, and it's going to print nothing. Why infinite? Because we're not updating I. We will only stop looping and exit this loop once I is no longer less than 10. Well, I starts at 1. It's certainly less than 10. Do we ever update I? Nope. So this is an infinite loop. And better is that we don't even print anything because I never changes, it's never even, and we therefore never print anything. Look at this second one. What's the only difference here? We finally update I. So you're like, okay, let's go. This is gonna print how many times? Pause the video, come back, and tell me how many times that will print the value of I. The answer is that this also is infinite and it prints nothing. And if you're a bit confused and you're like, why would this not print anything at all? And you're looking, well, think about this. Where are we updating I? We're updating I strictly inside the if statement. And you're like, oh, right? We're incrementing I, we're updating I strictly inside the if statement. So if I is even, then print it, and then and only then do you increment I, do you update I by 1. But since I is never even, that never happens, I will remain at 1 indefinitely, and this is an infinite loop. Finally, over here, you're like, okay, I see. I is now incremented, not part of the if statement, independent of the if statement. So inside the while loop, we say is I is 1 less than 10? It is. Is 1 even? No, it's not. So we're not going to print. Fine. Update I to now 2. 2 is less than 10. Is 2 even? Yes, it is. Print 2, then I becomes 3. Is 3 less than 10? Yes, it is. Is 3 even? No, it's not. Don't print 3, update I to 4. So we see that now we printed 2, we're going to print 4, we're going to print 6, we're going to print 8. We're not going to print 9. And then when we come to 10, we're going to say, is 10 less than 10? It's not, and we're going to exit the loop. So it's going to loop 9 times, and we're going to print 2, 4, 6, and 8. Here's one more example that I won't cover due to time, but I would encourage you to pause the video, try to trace through this code on your own, knowing that the input that the user will enter will be 2, 3, 4, 5, and 0, and try to come up with what the max will be and what number will be when you print those last 2 lines of code. This skill of tracing code is super important. Test that out, do it on a piece of paper, try to trace through it, and then once you're done to confirm, spend a whopping 120 seconds, 2 minutes, code it up to confirm that you do in fact get the correct output. So Python gives us 2 types of loops, and now we come to the for loop, and we're going to try to end this in around 8 or so minutes. The other type of loop, we've been covering while loops, now we come to for loops. Remember, while loops are condition-controlled loops. They're controlled by a condition. You can keep looping as long as that condition is true. Now, even though it's a condition-controlled loop, did we use it as a count-controlled loop originally? We summed maybe 10 values, or we asked the user to enter 5 values and we added them to sum and we had a count. You can use a while loop as a count-controlled loop. You can, but it's just more challenging. And that is where a for loop is appropriate. A for loop is strictly a count-controlled loop that loops a very specific number of times. So if you want to loop a specific number of times, 5 times, 20 times, that is when you use a for loop, and it is so much easier than using a while loop. So here is the overall construct that we've seen of a while loop. If we wanted to loop some certain amount of times, for example, if we wanted to loop, if we said I starts at 0 and we want to loop as long as I is less than 10, so 10 times, we have to update I at every iteration of that while loop. This was the overall construct of how we would do that using a while loop. So you can do it using a while loop, but it's just more challenging. Look at how all of this code that you see, let's now convert that to a for loop. That's the same code. Let me back up. We have this code, the while loop, that we're comfortable with. We could have set I equal to 0 while I is less than 10. We do whatever we want to do, and then we say I plus equals 1. We have to update I, of course, to exit that loop. That same logic can be accomplished with that one line of code for a for loop. For I in range, initial value, comma, end value. That's amazing. That's a big deal. So you have for variable in some sequence, and we're going to cover sequences a bit later on, but for now, for variable in sequence, do something. So an example of a for loop, for I in range, 4 comma 8, print I. Let me actually come over here to Thani. Let's make a new program. Let's just call this for loops. For loops. Did I hit open? File, new, save, for loops. And first, let's cover this example while loop. I equals 0. We said while I is less than 10, right? We can just print the value of I, and then we can increment I. So I plus equals 1, and let's run this code. We're going to get 0 through 9, right? So that exact same while loop, we could have coded that. Check how we do this with a for loop. For I in range 0, comma 10, print I. So here's your 0. For the while loop, we start at 0. We'll loop as long as I is less than 10. Each time we print I, and then we increment I. Well, now for I in range, this is going to go from 0 all the way to 10, not including 10, and it's going to automatically increment at every iteration, and we print I. So if I get rid of this, run the code, we get the same output. Which is easier? It's a no-brainer that the for loop is so much easier. We don't have to initialize, because the initialization is this value here. Nor do we have to increment, because the increment happens automatically. So it's effectively, if you didn't have to do that step or this step, you don't even have to do the conditional step. So this is a count control loop. We're saying just loop from 0 to 10, not including 10, and print I. And we just print, cool, gotcha, 0 to 9. Or let's go from 0 to 5. So 0, 1, 2, 3, 4, and we print out those values. So what if I said for I in range 4, 8, it's going to print 4, 5, 6, 7. Simply, we go from this initial value of 4 all the way to this value minus 1. So all the way up to 7. Another example, for Sarah in range 5. And the reason I do that is just so we understand that I is just a variable. For Kayla in range 0, 5, print Kayla. And all of a sudden, we get the same exact answer, 0, 1, 2, 3, 4. What if I wanted to loop from 2 to 6? That'll go 2, 3, 4, 5. For Kayla in range 2, 6, it'll print out 2, 3, 4, 5. Notice here, I've been putting two values inside the parentheses. Now, what if I only put one value? For Sarah in range 5, print Sarah, we get 0, 1, 2, 3, 4. So that kind of clues us in on something that, oh, I don't even have to put that initial value. If I don't put it, the assumption is it starts at 0. Meaning, if I said for Kayla in range 5, look at the output, 0, 1, 2, 3, 4. That's the same as 0, 5, 0, 1, 2, 3, 4. So if you don't put the starting value of 0 and you just put 5, the assumption is by Python, by the interpreter, that it is starting at 0. And so now we're going to show you, in fact, there's 3 different setups, if you will, that you can have within the range function. So you know that something's a function based off of the parentheses. If we only have one value, which is known as an argument, one argument or one parameter inside this function, we only have one number inside the function, such as range 5, this assumes an initial value of 0. If you have 2 arguments inside the range function, such as 5 to 10, the 5 is the initial value and the 10 is the ending value, remembering, of course, that we don't actually iterate that 10th iteration, or on 10, we stop at 5 to 9. We go from 5 to 9 here. 5, 6, 7, 8, 9. Only 5 iterations, so we go all the way to the ending value minus 1. And now, if there are 3 arguments, 3 numbers inside that function, the first 2 will be the initial value and the ending value. And the third one is the step size. So check this out. When I put 1, nothing changes. 5, 6, 7, 8, 9. But what about when I put 2? What happens here? 5, 7, 9. So we print I becomes, or Kayla becomes 5. Then we step by 2. Kayla becomes 7, and then 9. So let's look at some examples of that one. So here, if we had a step size of 2, let's say for Mike in range 1, 10, 2, the output would be 1, 3, 5, 7, 9. So let's make this Mike here. For Mike in range, we had here 1, 10, 1, 10, 2. So starting at 1, then add 2 to 1, we get 3, add 2, we get 5, add 2, we get 7, add 2, we get 9, and of course 10 is the upper limit. Let's run this again, and let's make this a 3, the step size of 3. So this will go from what? 1, add 3, 4, add 3, 7, add 3, 10, and we don't do that. We stop before 10. So 1, 4, and 7. So what if I wanted to go from, how about 1 to 100? a step size of 10. This would be 1, 11, 21, 31, 41, all the way to 91. If I wanted to start at 0, this would have been 0, 10, 20, 30, 40, all the way up to 90. What if I wanted to print 100? I could have gone all the way to 101, and that would print my 100 value. So let's look at more examples here. Step size of 5 from 0 to 30. Step size of 5 for Barbara in range. So again, what happens is Barbara is going to get those values. Barbara becomes 0. Then Barbara gets the value 5. Then 10, then 15, then 20, then 25. Barbara will not get the value of 30. 0, 5, 10, 15, 20, 25. So this last value, this third value here, is the step size. One more time. So if I said 0, 5, 1, this is going to loop from 0 to 4, only with a step size of 1. That would be identical to saying for Bob in range 5. Print Bob. Because if we only put one value, the assumption is that we're starting at 0, and the assumption is that the step size is 1. So if you just put 5, notice we're going to get the exact same thing. We get 0, 1, 2, 3, 4, and then we get 0, 1, 2, 3, 4. So we have the 3 parameters. If you only have one parameter, that's going to loop from 0 up to that value. You have 2 parameters. The first parameter is the first argument. Argument and parameters are synonymous. The first argument is going to be the starting value. The second is the ending value. And if you have 3, the third is the step size. So with that in mind, how would you count backwards? What if you wanted to count backwards? And here's the answer. We simply make that step size negative. This goes from 5 all the way down to 0, but not to 0. We're not going to do that final iteration when x becomes 0, but now the step size is going down. So the output here would be 5, 4, 3, 2, 1. Let's look at one more. What if I wanted to do for Michaela in range, and we want to, how about loop from 50 down to 0, not including, let's say including 0, and including 0 by a step size of 5. But notice it said loop from 50 down. So therefore, 50 is the starting number. When are we stopping? We'll cover that. But the step size is a -5. And here we're going to print Michaela. Cool. So what do we put here? If I put 0, this would loop from 50 down to 0, and it would print 50, 45, 40, 35, 30, 25, 20, 15, 10, 5, but it would not print 0 because by putting 0, we're going to stop 1 before 0. So how do you print 0? If you want to go all the way to 0, including 0, you have to go 1 farther, but we're not going to print that one. So here's the output, 50 all the way down to 0 with a step size of 5. What if you wanted a step size of 7? No problem. 50, 43, 36, and so on. Step size of -10. And this will go 50, 40, 30, 20, 10, 0. So we can see how straightforward these for loops are. So much easier to do a counter-controlled for loop. If I wanted to convert that to a while loop, what a disaster. I'd have to say what? Count equals 50 while count is greater or equal. How about greater than -1? I need to print count. And then I need to say count minus equals 10. I think I did that correct. We should get the same output. But how much harder? Those 4 lines of code compared to just these 2 lines of code, so much simpler. So suppose the input is this. What is the output? Once again, I'd like you to trace through this, pause the video, trace through, try to come up with the correct output, and then code it and see if you got that output correct. Here's one where it says convert the following for loop to a while loop. We want to have the sum starting at 0, and we want to sum all of those values. Let me code that very quickly. So we have sum equals 0 for I in range, was it 1001? 1001. Sum equals sum plus I. Convert that to a while loop. So that means to do a while loop, we need a counter. So we still have to have a sum. And now we would have had to have a counter that's going to start at 0, because this I in range, remember, it's effectively, since I only put 1001, it's really 0, 1001, and then 1 here, right? It's the same thing. So I need a counter that's going to start at 0. Then I need to say while count is less than 1001. Sum equals sum plus I. So we're adding I to sum. And then we need to update our count plus equals 1. That would be the exact same while loop. Or I should have used the same variable I, which is what I did here on the slide. Count the number of iterations of each of these loops. Assume n is 10. So here we have count is 0. While count is less than 10, count plus equals 1. We can see that we're going to have 10 iterations here because we're incrementing each time, starting at 0 to less than 10, we have 10 iterations. Look at B now. For count in range 10, this will also be 10 iterations from 0 all the way through 9. Now what if n is 10, but now we start count at 5, while 5 is less than 10, and every iteration we increment by 1? So 5, 6, 7, 8, 9, that will be 5 iterations. And then finally on this last one, while 5 is less than 10, we're going to add 3 to our count. So while 5 is less than 10, that's true. So now we're at the first iteration, and count becomes what? Count becomes 8. That's the first iteration. Is 8 less than 10? It is, that's true. We're at the second iteration. Count now becomes 8 plus 3, 11. 11 is not less than 10, so we had 2 iterations. In summary, we've seen 2 loops. That's a quick overview of for loops, but it's really that simple. That's how easy for loops are. And we'll practice more with them. But which loop should you use? Let's simply end with this. Which loop should you use? Because each loop has a purpose. Should you use for loops? Should you use while loops? I would say it depends on what your goal is. When you know you have a certain number of iterations that absolutely need to be executed, that's when you use a for loop. When you know exactly how many, that's exactly when you use a for loop. When should you use a while loop? When you don't know how many times to iterate. When you need to iterate a potentially open-ended number of times as long as a given condition is true. So that subtraction example, when we ask the user, how many times would you like to, or how many questions would you like to answer, and they say they want to answer 8 questions, a for loop would be most appropriate. But when we converted that example to now ask the user, would you like another question? Would you like another question? Would you like another question? That's now a while loop. So a while loop, we loop until a condition is no longer true, or we loop as long or while that condition is true. That's when a while loop is appropriate. This has been fun. We're going to pick up next time with continuing for loops and then covering more examples. As always, reach out if you have questions. Leave a comment. Take care, everyone.